Chavis on the UMEC webinar series, and this month is about urban mobility. And Dr. Chavis will talk about shared bus bike lane safety analysis. And Dr. Chavis, all yours. Thank you.
Thank you. Thanks for having me. So this study looks at the shared bus bike lanes that were installed in 2017 in downtown Baltimore. So I'll start with what's a shared bus bike lane. So really they're dedicated bus lanes that they allow cyclists to also occupy. So it's a way to accommodate both buses and cyclists when you have very limited space. And so basically the goal of these lanes is largely to increase the efficiency of buses, but in doing so, they're also allowing cyclists to occupy the space. Shared bus bike lanes are a lot less common in the US than they are in Europe. At the time of the study that we did, there was 27 corridors in the US with shared bus bike lanes. So here you can see some of the selected corridors in different cities in the United States. They're pretty short. Baltimore is unique where we actually have a network of shared bus bike lanes, so that allowed us to do this study and to gain some additional insights. So here you can see the shared bus bike lanes in Baltimore. So if you're familiar with Baltimore, the harbor is kind of right below where these bus bike lanes are. And so we have two types of shared bus bike lanes. The first one are permanent bus bike lanes. They're shown in the purple. These are shared bus bike lanes that operate 24/7. Whereas the ones in green are peak only bus lanes. So outside of the operation, they are parking lanes, and then they are converted into shared bus bike lanes at key points. So here on Charles Street, this is a one-way street that runs north out of downtown. It's only operating in the PM. St. Paul Street is operating in both the AM and PM during select hours. And then here also on Baltimore Street. So when MTA was deciding where to install the facilities, they looked at various performance measures, with which one I'm showing here below, which was the frequency of buses along key corridors. So you can see kind of this network of where the high frequency buses are running, and most of the shared bus bike lanes were installed right here in this central part of Baltimore, where we see a convergence of several lines downtown. So this is what they look like. So the permanent lanes are all painted red. Where vehicles are allowed to enter, the paint marks are broken, indicating that a vehicle is allowed to enter the lane in order to turn right at the next intersection. And so the dashed red lines means that vehicles who are making right turns are allowed to enter. At all other points, only buses and cyclists should be operating on those lanes. And then of course, all other vehicles should be operating in the general purpose lanes. Emergency vehicles and school buses are also allowed to use the bus only lanes. So in 2019, MTA did conduct a study on the operation of these facilities. They did a before and after analysis that focused really on travel time on these facilities, being in the bus lane as well as in the general purpose lane, and then looking at the number of bus crashes on these facilities as well. And so you can see that for bus travel time, which I'm showing you in the table on the right side, that the travel time for buses generally decreased on most of the corridors, with the exception of a couple. And it said on average, the travel time on the general purpose lanes So the ones that all the other vehicles are operating on average, only increased by about a minute, but it was variable depending on the location. The number of bus crashes also decreased by about 12%, although 3/4 did show a slight increase in the number of crashes. And so that kind of leads us to our study and what we did. So the goal of this study was to try to understand more of the nuanced behavior of how buses and bikes are sharing this space. And so we wanted to really understand kind of that microscopic travel behavior on shared bus bike lanes. So in order to do so, we contracted out to fly tethered drones at 11 locations across the shared bus bike lane network. Technically, 9 were shared bus bike lane locations and 2 were just regular bus lanes, so that we can compare, which we're still doing. That part of the study is still ongoing. So we collected data, up to 6 hours of data at each location, 2 hours in the morning, 4 hours in the afternoon. We conducted volume counts on the shared bus bike lane and the general purpose lanes. And then we also conducted video inspection of a subset of the data to look at how the buses and the cyclists were interacting on the corridor. So here are some screenshots from the drone footage. You can also see how we conducted the screen line counts and travel time counts. So for the bus lane, we did volume counts by mode. So we looked at the number of buses, bikes, scooters, as well as other vehicles who are operating on that lane. For the general purpose lanes, it was just a count. We did not separate by mode for the general purpose lanes. We also looked at the running travel time, so the travel time it took from a vehicle to go from the first screen line to the last screen line. That did take into account signal timings. If a bus was boarding and alighting, that time was also included in those travel time calculations. So here you can see some of the data on the 9 shared bus bike lane corridors that we selected. So you can see they're a varying length, mostly just due to what we were trying to capture in that space. They all had a bus stop, whether 1 or 2 stops along that corridor length. You can see the average annual daily traffic, also the bus and bike traffic as well. And we looked at different slopes, which we're still kind of completing the bike analysis to see if the travel speed for the cyclists varied with the slope of the road. Here you can see the crash data from 2015 to 2018. It's all crashes, not just those that involved a bike or a bus, and then also the fatal crashes as well. So here is the graphic of the location. So the stars represent where we set up the drone. And then the red portion is the length of the facility that we were looking at when doing our video observations. You can see the bike network is also overlaid. So the green lines are our separated bike facilities that were there at the time of the study. And then you can see the shared bus bike lanes, how that kind of fills in this area. So you can see we have several kind of east-west looking locations, and then some going north and south, leaving and entering downtown. So for the morning period, we looked from 7 to 9 a.m. To kind of get that morning peak period. In the evening, we chose a 4-hour window, going from, I should have said from 2 to 6 p.m., where 2 to 4 was kind of the start, looking at that off peak, going to the start of the peak period, and then 4 to 6 for the peak period. In total, we had about 55 hours of video data. We counted over 41,000 vehicles along these corridors. about 8% of those overall vehicles were operating on the shared bus bike lane. We observed over 1,200 vehicles and 167 cyclists on the shared bus bike lane. So I should note that there could have been other buses who were operating in the general purpose lane. If they were in the general purpose lane the entire time, they were not counted separately. They would have been counted with the general purpose vehicles. So the bus count are those that were on the shared bus bike lane at least a portion of the time. And then we did capture 2 locations that did not have shared bus bike lanes. The first one was St. Paul Street near North Avenue, which has a very narrow bike lane, very narrow bike lane, no bus, but there is a bus route that operates on that street. And then the other one was a portion of Guilford that has a separated bike lane. And repeat of what I showed before. So here's looking at the morning traffic counts at each of our 9 shared bus bike lane facilities. There's no data for Charles Street because it's a peak only lane that only operates in the evening. So one facility in particular stood out amongst the others, and that was at Guilford between Lexington and East Fayette Street. So what you see here is the volume of traffic given as vehicles per hour per lane. And what makes Guilford quite unique is that the volume of vehicles operating in the shared bus bike lane, which is shown by the bar chart, is pretty comparable to the volume of vehicles outside on the general purpose lanes. And that's because there's a really high volume of right turning traffic that is using the shared bus bike lane at that location. But despite the fact that there is a high volume of vehicles operating on that facility, we actually saw the highest number of cyclists and scooters as well on that facility at 18. In this chart, I'm combining cyclists and scooters. Scooters are still pretty minimal, even though we did observe, a couple, maybe like 2 at a time. But most of these counts were cyclists. And you can see that there was 26 buses per hour on that facility as well. The number of buses, the number of cyclists was still pretty low at most locations. The second highest one was Pratt Street. And this one is a little bit tricky because there is a shared bus bike lane operating, but there's also a separated bike facility that runs parallel to it on the street. So we counted cyclists who were actually in both, whether it be the shared bus bike lane or the separated bike facility. So this one is kind of an asterisk facility because of the way it's operated. You can see the locations that had pretty high bus volumes. Baltimore Street between Hanover and Charles, as well as Lombard Street at Hopkins Plaza in Hanover. And these are really close to each other. So the locations that I'm circling in red are places where their vehicles should not be turning right. So they are the one-way street that's intersecting is actually a left turn and not a right turn. And so we shouldn't be seeing vehicles operating on those facilities, but you can see that there are vehicles there despite the fact that there's nowhere to turn right. Pratt Street is a little bit different because there is like a merge. So even though there's no place to turn right, sometimes when merging, the vehicles are using the shared bus bike lane before they merge into the general purpose lane. But you can see that on those facilities that are highlighted in red, all those vehicles who are present would be considered people who are not using the facility properly. Here we're looking from 2 to 4 p.m., so just before the peak of the afternoon rush. Here, the rate of buses drops to about 20 to 30 per hour. And you can see at this point in time, Pratt Street, which is right there on the harbor in the tourist area, had the highest volume of cyclists and scooters at that point in time. And you can see Guilford was about a third of what it was previously. Here's looking in the PM peak from 4 to 6 p.m. So what we noticed is that with the exception of the first location of Guilford Avenue, all the other locations actually had higher cyclist and scooter volume in the afternoon than what they had in the morning. Here I'm highlighting once again the locations where we should not see vehicles operating in the shared bus bike lane. And one thing that stands out is Fayette Street between Calvert and St. Paul that has a pretty high number of vehicles who are using that facility in violation. The other thing I want to highlight are two of our peak only lanes, Charles Street and St. Paul, which run north and south through the city. So you can see that these facilities have, particularly Charles Street, a high number of vehicles who are using that lane. The number of cyclists and scooters is somewhat low, as is the number of buses, which explains why it's probably only a peak only lane. But these are operating a little bit different. And what we'll see later is that there's a high number of parked cars often on the peak only lanes, particularly on Charles Street between Preston and Biddle. So here was looking at the travel time and block density, which was measured as vehicles per miles per lane. So I'm showing the median travel time at the different time periods. And I just want to highlight a couple of locations. So of course, that Guilford Avenue, this is the location that had the high volume of right turning cars. What's interesting here is we can see that the average block density in the bus lane was actually higher than the general purpose lane. And that's the only, and it's a high density on top of that. And you can also see that for vehicles who are using the bus lane, it takes about 57 seconds is the median travel time, whereas on the general purpose lane, it's 53 seconds. So in this place, you can see that the travel times are pretty comparable on the bus bike lane as it is in the general purpose lane. And that's because of the high volume of right turning cars. Other location I want to highlight was Fayette and Calvert between St. Paul, which had that high volume of violating cars. Those are the ones who these vehicles should not be operating on this lane. And what stands out, and maybe what explains why we saw so many vehicles who decided to use the shared bus bike lane, is because of the difference in travel time between the general purpose lane and the bus lane. So you can see that in the afternoon, for example, in the PM peak, it takes 107 seconds to traverse that distance on the general purpose lane, but vehicles who use the bus bike lane was able to get through in 40 seconds. So that difference in travel time was quite great, which would entice more people to use the shared bus bike lane. And you can also see the difference in density on those facilities at that time as well. So we ran some regressions actually at each location. I'm just going to show two for the sake of time. For many of them, we didn't see enough bike volume to really run a regression. But for example, Guilford, which was one of our more utilized corridors. So this is that location one that I was saying has a high volume of right turning cars. So you can actually see that this entire stretch is hash, indicating that vehicles can enter throughout this entire block length in order to turn right. We still see bikes using this facility, and a good reason is probably because this lane has the shared bus bike lane, which is shown in red, but it also has a bike only lane that runs next to it along this portion too. So it does provide cyclists with their own travel lane. So what we saw here when we ran the regression was that first we looked at the travel time to buses, And we looked at how the bus travel time varied depending on the number of vehicles who were operating the shared bus bike lane and the number of cyclists that we saw. And so what you can see is that the bus travel time increases with the number of vehicles, and it was significant, but it was not significant with bikes, indicating that the cyclists on this facility were not impeding the travel time to buses. And in fact, in all of our locations, the number of cyclists did not impact the bus travel time, but that's also because, as you saw before, the volume of bikes is still pretty low on these facilities. And then here we just reran it without the inclusion of bikes. Then this one, I'm showing the travel time to cyclists as a function of the number of vehicles who are on the shared bus bike lane, as well as the number of buses who are on the shared bus bike lane at the same time. And in this case, both the number of vehicles and the number of buses significantly impacted a cyclist travel time, whereas having a bus on the corridor had more of an impact than having a vehicle on the corridor. And here I'm just showing you at a second location. This one is near City Hall in Baltimore. And for this one, the volumes of vehicles and cyclists were really low. And so we see that neither of them significantly impacted bus travel time, indicating that the travel time was pretty consistent throughout the time of the study and was not dependent on if there was bikes and other vehicles, particularly because of the low volumes that we saw. And then in the bike travel time regression, having a vehicle being on this shared bus bike lane at the same time as the bike did impact their travel time, but having a bus on the location at the same time did not significantly impact a cyclist travel time. So from here, we wanted to start to look at what's happening when there is a bus and a cyclist on the lane at the same time, or a bus and another vehicle, or a bike and another vehicle. So it's a lot of data here, but what I'm showing is we're just looking at, does a bus and a bike share, are they on the corridor at the same time? And so from the quality counts data, there was 1,342 instances where either a bus or a cyclist was on the lane at the same time of another vehicle. However, only 6% of those instances was it a bus and a bike being on the corridor at the same time. The majority of those instances involved a vehicle who was using the corridor, either to turn right or were in violation and just using it to get by. So if I focus here first on column A, which is looking at the total number of bus and bike interactions, you can see that they're pretty low still. Guilford and Lexington, which had the highest volume of bikes that we saw, particularly in the morning, there was 14 instances that there was a bus and a bike who was on the shared bus bike lane at the same time. And so what's interesting is when you look at for bikes in particular, because we know that they're the ones who are the most vulnerable, even at this instance where we see the most buses and bikes being on the corridor at the same time, only about 26% of the time was that was there a bike that was on the corridor at the same time as a bus. So that still was only about a quarter of the instances where a cyclist was on the shared bus bike lane. However, a cyclist was expected to interact with a vehicle or be on the lane at the same time as a vehicle 100% of the time. So if they were using that corridor, they had to be on it with other vehicles. And you can see for some of the locations, it was pretty low, where the chance of a cyclist really having to interact with another vehicle is low, but perhaps because of the bus volume, the chance of interacting with a bus is relatively high. And so what we, and here you can see the buses that have to interact with the vehicle. And I'm highlighting the locations where we should not see vehicles once again in the lane. And you can see, looking at that Fayette and Calvert Street, that having that a bus was in the lane with a vehicle nearly half the time during the peak periods when the travel times were longer, as a vehicle who should not be there. Now, it doesn't mean that that vehicle who was in the lane had actually impacted the bus's operation. And so that's where our video review came in. So we wanted to actually see, like, okay, so yes, we know that in some locations we have vehicles who are not abiding by the rules, they're still entering the lane, but how is that actually impacting the travel time and the operations of the bus in particular? And this one is looking once again at Charles and Biddle. This one is the peak only lane, and you can see that over 3/4 of the time, a bus had a vehicle in the lane at the same time. And in fact, a lot of these were parked cars. And so this shows you that location of Charles Street going northbound. This is during the peak only time, and you can see all the vehicles that are parked here. The peak only lanes aren't painted for one. And so you can see that the buses aren't even able to utilize the shared bus bike lane because of the number of cars that are parked blocking it. So what we did was we reviewed some of the bus data. So based on looking at that analysis where we saw that there was a bus and a vehicle that was sharing the shared bus bike lane at the same time, we reviewed 822 buses. And so we reviewed 822 out of the 1,200 buses that we observed in our entire study period. And so how we chose those buses was we included buses that were sharing a lane with at least one other vehicle, or also buses that had a travel time that was over twice the mean travel time. So just to see what was happening in those instances. We reviewed all the cyclist data since it was much smaller. So we reviewed all the cyclist data that we had at the time. When we started doing the analysis, we realized that some of the video data was missing. And so while we were able to go back and include the missing data in like the volume and travel time study, we did not go back and review the missing 30 cyclists video data just due to time limitations. So here you can see some of the summary of those bus interactions, and I apologize, this column is a bit mislabeled. This is basically an interaction, whether it be with a vehicle, another bus, or a bike. What's interesting is even though we had a lot of instances where a bus was on a lane with another vehicle, another bus, or or a cyclist, about 90% of the time it did not impact their operations. So we said the bus interacted with the vehicle if it required them to maneuver around, adjust their speed, basically if it required the bus operator to do something different than what they were doing at the time. And so that's what we counted as a bus interaction. So just because they were on the lane at the same time, it doesn't necessarily mean that it impacted the bus at all. So of those that had some sort of interaction, here we can see the count of what they were. So the majority of the time, it was a parked vehicle that impeded the bus's operation. You can see that is about 60% of the time, 63% of the time, followed by passenger cars. And so these would be vehicles that might have slowed down the bus that were in the lane. Bikes, we only observed 5 instances of when the presence of the bike actually impacted the operation of the bus. And then there was 14 instances where another bus impacted the operation of a bus. And so usually that's a bus that was boarding and alighting. Maybe the other bus didn't need to stop, and so they would have had to maneuver around the bus that was that was stopped in the lane. And so the three locations that had the highest number of interactions, so location 2, 8, and 9, all of those had a high number of parked vehicles in the shared bus bike lane. So we looked at what the bus did when they needed to interact with the vehicle. So one of the good things that came out is that, I mean, there was only 5 instances, but the 5 instances where there was a bus who was impacted by a bike, the bus did wait. So they did not try to maneuver around the cyclist. Sometimes when the bus was stuck behind another bus, they waited behind about 57%, but when cleared, they did pass from the left in order to get around the stop bus. Obviously, with a parked vehicle, they needed to maneuver around it unless the vehicle was about to move. For passenger cars who was moving, but they were behind, majority of the time they waited behind the vehicle. And same with pedestrians who are in the way. So we did see that the buses did not try to maneuver around cyclists or pedestrians. Here's just some video clips to kind of see some of the operation of these lanes. So here we have a stop car, and so you can see how the bus is having to maneuver around. They're getting slowed by the queue of cars, where if that vehicle wasn't parked, they would not have had to slow down and been impacted by the queue at the light. Here we're showing that Guilford Avenue stretch. We had a parked car also blocking the lane. And so you can see that the bus is having to merge over, and that queue of vehicles at the light is impacting their travel times quite a bit. And so parked cars really had the biggest impact on the operations of the facility. Okay. Throughout the footage of the buses that we observed, I think the 822 buses that we observed, we only observed one kind of near-miss collision instance. And ironically, this was with a police car. And so in the clip, essentially the bus is coming down the bus only lane. Here you have the police car coming down. The police car wanted to merge into the shared bus bike lane and kind of started to merge, not knowing the bus was coming down. The police car did end up yielding to the bus without any incident. And then the police car sat in the bus bike lane for over 30 minutes, blocking the bus bike lane operation. But that was the only instance that we saw that looked dangerous in our video review of the buses. So then for the review of the bike data, we looked at 132 footages of cyclists, which was all that we had at the time. Of those 132 instances, there was only 20 instances that a cyclist had to interact with another vehicle. There was one location that we couldn't review, which was Baltimore between Arch and Green Street. And that's because of the angle of the video was kind of weird, and we couldn't clearly see cyclist movement in that video. But you can see parked cars and passenger cars was the least amount of interactions. And really it was a bus stopping to pick up and drop off passengers that the bicyclists had to interact with. So here we're just looking at what travel lane the cyclists chose to use the majority of the time. Majority of the time they did use the shared bus bike lane. There was a few instances where we saw them on the sidewalk the majority of the time. Some of these locations have pretty high bus volume. So you can see here at Guilford and Lexington, they even went into the general purpose lane to maneuver around the buses. And this Pratt and Calvert, it was classified as a sidewalk, but it's really not the sidewalk. It is the, there's a path that's kind of in alignment with the sidewalk that is designated for cyclists to use. So this is really a bike lane that they're using instead of the shared bus bike lane. So why be on the road with other vehicles if you can be in a separated facility? So here we're showing like this flow chart of of the bike interaction data. So you can see here we're looking at what lane they were in the majority of the time. So of course, most of the bikes that we saw were in the bike lane the majority of the time. Here we're looking at what type of vehicle they interacted with. Was it a bus? Was it a moving passenger car or some sort of parked vehicle? And so what we see in the next one is what decision the cyclist decided to do, where the decisions were to wait behind the vehicle, use the sidewalk, or pass to the left. So you can see, let's start with those vehicles that are using, those cyclists that are using the bike lane. The majority, of course, had to interact with the bus. Some interacted with a parked vehicle. Of course, so anytime there was a parked vehicle blocking the lane, the cyclist chose to use the sidewalk. When they had to interact with the bus, most of the time they waited behind the bus, but on a few occasions they did pass to the left of the bus. When there was a passenger car that was slowing them down, generally they waited behind the vehicle for the passenger car. And basically, when we saw them using the sidewalk, it all instances it was because when they were using the sidewalk, there was a parked vehicle, so they just kept using the sidewalk. So this is just a couple of videos looking at some bike operations. It's really hard to see, but there's a cyclist in front of the bus. And so you can see that the bus is just waiting for the cyclist. They did not try to maneuver around the cyclist here. And then soon that bus is gonna have to soon that cyclist will have to maneuver and wait for this bus to go through. On this one, on the right, we have a cyclist who's using the bike lane. They're on the green part here. It's kind of hard to see. And then you can see the vehicles kind of trailing behind them. But this one, they could operate pretty freely. The other thing we looked at was what was the effect of when vehicles entered the shared bus bike lane earlier than what they were supposed to do. So they entered before the hash marks. We saw that 32% of the time passenger vehicles entered early. When we were looking at the footage that we were observing for the buses, we looked at that at the same time. And 69% of the time when a vehicle was entering early, they were not intending to turn right. So they were really just entering early to do a through movement. Of those that entered early that were not intending to turn right, they slowed down the bus about 64% of the time. So, however, when the vehicle did enter the lane at the appropriate time as intended, most of the time they did not slow down the bus, right? So here we're looking at vehicles that did not enter early. And so of those that did not enter early, the majority did not slow down the bus. Some did, but overall, the majority did not slow down the bus. Whereas here, those vehicles that entered early, we can see that more slowed down the bus than did not. And then you can see here, the majority of these vehicles were turning right. So they entered the lane when expected, and they were making the right turn lane. So these vehicles here, they did enter at their appropriate location, but they did not turn right, and they decided to go straight instead of turning right. And so I'll kind of, in conclusion, and I'll play a clip as I kind of talk through some of the things we observed. Bikes did not really impact the travel time for buses, largely because there wasn't a lot of bike volume, but bikes were impacted in their travel time by buses, particularly boarding and alighting passengers, as well as with the right turning cars. We didn't really observe too many instances of unsafe operations. We were really excited to see that MTA operators never attempted to pass a cyclist. But really, what affects operation of these lanes the most is right turning cars, and then cars who are entering the lane who are not turning right. And so what we saw is that enforcement is really critical, particularly when you look at the peak only lanes, because they're not painted and because they're often operating as parking lane in the off periods. Enforcing them is important. So this is an example of that on Charles and Biddle. And what was actually kind of cool is we actually observed parking enforcement in this video. So here you can see the stop cars, and later we'll actually see the parking enforcement person getting out of their cars and shooing these vehicles onward to ensure that the lane is clear. So a couple limitations. We only observed each location at one time period once, so it may be hard to come up with some generalizations just due to the limited amount of data that we had. One thing that would be of interest that we didn't get to do was to really see like what type of cyclists actually feel safe to and comfortable to use a facility like a shared bus bike lane. It's definitely not for the rider who is a little bit scared because you have a lot of vehicles that are within your space. Even though we did see that it was pretty safe, I'd be curious to see to learn more about what type of cyclists actually will take a facility like that. So that's where we have concluded the study. Right now, I'm actually working with professor in electrical computer engineering, where we're trying to automate a lot of what we did using some machine learning techniques. So that hopefully if we continue to kind of do this drone video collection data, we don't have to spend as much labor and time to do these analysis. It's a little bit difficult on the machine learning side because the video is always moving because it's not a fixed camera. And so there are some challenges posed in that case. So with that, thank you. And I will take any questions that you guys may have.
I have a question. How you doing?
Good.
My name is Travis. I'm an industrial systems engineer. When y'all was watching the videos, how did y'all count the vehicles that use the lanes? Like, did y'all have a software? Or did y'all just do it like by eye? It
was a mix. So actually the consultant, which was Quality Counts, did it. But essentially they're watching it by video. And when a vehicle enters the lane, like they press the button, and then when it leaves, they release it to get the travel time. And then each time they did that, it counted the vehicles. So it was mostly manual. And the only real automation was just like calculating the travel time. So it was very time intensive.
Okay, thank you.
Mm-hmm.
Hello, hi, Dr. Chavis. I have a question or two.
Sure, hi, Dr. Pitts.
How are you today?
I'm good.
Good, good. Want to ask a couple of questions. One was about the drone. You earlier showed a picture where it was tethered. What was the reasoning for using a tethered drone versus one that would be able to just fly with, unmanned without a tether?
So we flew, I think the length of time that we were flying the drones and trying to keep it in one location was one reason. Also, it was connected to the battery pack at the ground level. And that's also what the consultant suggested in terms of the type of drone to fly.
Oh, so the drone was being powered through the tether to last longer, or was it just more for stability and keeping it in place?
I think primarily stability. But I do think there was a battery pack on the ground that I think it might have actually been powered through the tether too, but I'd have to confirm.
Okay.
Yeah.
Okay. And let us know, because we do drone work. We can help.
Yes. Sounds good. Help.
I have a whole lot of them. So what the other question I have is about, I don't live in Maryland, so I don't know a lot about the bike lanes and the buses and cars and all sharing. So this was a really nice project. It gave me a lot of enlightenment. The question I have is, what are the laws concerning these people who are parked versus, I assume cars can get in that lane to turn, to make right turns.
Yeah.
But what are the laws against the folks, or are they giving them fines or ticketing if they
It's a
are caught,
$90 fine.
if they're caught?
It's a $90 fine. And right now, what they're trying to do is pass legislation to do automated bus lane enforcement, where if they have a camera on the front of the bus, they can automatically ticket you by reading the license plate. Because right now, all the ticketing is done manually. So you have to have a officer who catches you to get the ticket right now.
Okay, so let me just throw this at you. One of my senior project groups did ticketing enforcement with drones,
Mm-hmm.
and it got pictures and really sharp pictures of license plates and placard tags and things to identify the violators. That might be something that can be incorporated down the line.
Yeah,
So
definitely.
let's talk about it.
Let's do it.
Okay, thank you.
Mm-hmm.
And there is a question in the chat box. Thank you for the informative presentation. Did you witness any incidents related to pedestrians crossing at crosswalk that influence bicycle or bus movement in the SBBLs?
No, we did not. Though to be honest, I'm not sure what percent of pedestrians we actually observed when we were going through the video observations, because we targeted the bus presence and the bike presence to know when to look at the videos. But no, we didn't see anything with pedestrians.
Thank you.
Yep.
Hello, everyone. Thank you, Dr. Chavez. That was great. A short question. Did you notice any difference between the data that you gathered among the corridors you studied, between those that were related to the connected infrastructure for bikers versus those that were just specifically in the corridors with sharing bus lanes?
So we haven't done the comparison yet. And it's going to be kind of tough because we only looked at two corridors, and they were so different. So the first one that we looked at was St. Paul Street. And that one's a little odd because the bike lane is pretty narrow. And so from our first observations, actually a lot of cyclists would move to the sidewalk, particularly when there was like a bus, because the bus really has to use the bike lane in order to get down that lane because it is too narrow. So that facility is a little bit unique. And then the other one that we looked at, the volume of traffic was actually fairly low. So it's a pretty low stress corridor. So we're not sure if we can make a lot of generalizations just due to the limited number of observations that we have and just how unique each of those locations are. Any other questions for me? If not, thank you for your time. My contact information is there. I'm happy to discuss this more offline with anyone if you have questions as they come up.
Thank you very much, Dr. Chavez, for the great presentation. And if there is no other questions, we can have a 10-minute break.